In this chapter, we'll discuss the chemistry of amines and heterocycles. Many amines exist in nature naturally as alkaloids. Alkaloids are naturally basic compounds that are typically used for self-defense by plants. Typically, alkaloids will have a cyclic amine. They're usually addictive and toxic, and their names typically end with INE to indicate the fact that they are amines. An example of an alkaloid is atropine, which is an alkaloid isolated from nightshade, and is used to dilate pupils, among other things, in medicine. Many alkaloids have useful properties, but unfortunately many of them are also addictive. For example, caffeine, nicotine, and morphine are all examples of alkaloids. Simple primary amines can be named as alkylamines. More complicated amines are typically named by using the suffix amine in the place of the letter E at the end of the alkane or cycloalkane. We typically use diamine and trimine for compounds that have either 2 or 3 amino groups in the molecule. There are also derivatives of amines called anilines, which typically contain an amino group attached to a benzene compound. Here's a few examples of primary amines and how they're named. The first one is terbutylamine, since it contains a terbutyl group attached to an amino group. The next one is another simple amine, which is a cyclohexyl group attached to an amine, so its name is cyclohexylamine. A slightly more complicated example has 2 methyl groups at the 4 position of the cyclohexane. So this is named as 4,4-dimethyl cyclohexaneamine. Now note that you can use either naming system, either an alkylamine naming system or replacing the letter E of the alkane with the amino or amine suffix. Either system is acceptable by IUPAC rules. Aniline, of course, is a compound we previously discussed, which has an amino group attached to benzene. And if we add other substituents, we want to follow the typical naming rules for aromatic compounds. And down here we have an example of a diamine. It has 4 carbons. So this is named as 1,4-butane diamine, since it contains an amino group at the 1 position and at the 4 position. For secondary and tertiary amines, we typically will name them based on whether they're symmetrical or unsymmetrical. If they're symmetrical, we will give the prefix di, tri in front of the alkyl group, followed by the suffix amine. As an example, we have 2 phenyl groups attached to a nitrogen. This is a secondary amine, so we name it as diphenyl to indicate the 2 phenyl groups, and then amine. The next example has 3 ethyl groups on an amine, so we name it as triethylamine. For unsymmetrical secondary and tertiary amines, we typically give the prefix N to indicate that there is a substitution on the nitrogen, followed by the smaller of the alkyl groups. If there are 3 alkyl groups, then the 2 smaller alkyl groups will both have the prefix N. And at the end of the name, we want to have the parent name, which will have the suffix amine. Here's a couple examples. We have a compound, a tertiary amine, that is unsymmetrical. It has a propyl group and 2 methyl groups. So the 2 methyl groups are smaller. And so we give those 2 groups in front of the name. NN dimethyl tells us that we have 2 methyl groups on the nitrogen rather than anywhere else on the parent chain, followed by the parent name, which is propylamine. The next example has a methyl, an ethyl, and a cyclohexyl group. So the methyl and the ethyl will go in front in alphabetical order, starting with ethyl. So N-ethyl, N-methyl, followed by cyclohexylamine. Occasionally, we might need to give the amino group as a substituent when there are other functional groups with higher priority. Here's a few examples to illustrate this. We have a compound that has a carboxylic acid and an amino group. The carboxylic acid is a higher priority group, so we name it as a butanoic acid molecule, which has an amino group on the second carbon, so 2-amino butanoic acid. The next example has 2 amino groups on benzoic acid, and they are on carbon 2 and 4 relative to the carboxylic acid, so 2,4-diamino benzoic acid. Lastly, we have an amino group on the 4th carbon of this ketone, so we name this as 4-amino 2-butanone. In this question, we're going to try to name the following 2 amines based on the IUPAC rules. So in the first example, we have a secondary amine, an unsymmetrical secondary amine. And in the second example, we have an unsymmetrical tertiary amine. The first example in this question has a unsymmetrical secondary amine with a methyl group and an ethyl group. For these compounds, we typically will give the smaller of the 2 alkyl groups first as a substituent on the nitrogen. So we write that as N-methyl, and then the larger alkyl group will be part of the parent name, and so the name or the parent name would be ethylamine. In the second example, we have an unsymmetrical tertiary amine. We look for the largest alkyl group, which in this case is the cyclopentyl group. That's going to be part of the parent name. The smaller groups will be substituents on the nitrogen. We put them in alphabetical order, and we have now for the name N-methyl and propyl cyclopentyl amine. Although we won't spend too much time on naming heterocyclic amines, it's important to know the basics of naming these compounds. Heterocyclic amines, as you might recall, are cyclic amines. We saw a few examples in the aromatic chapters. These compounds typically will have their own parent name depending on which heterocycle it is, and usually the nitrogen will be position 1 in naming these compounds. As an example, we have pyridine, which is essentially a benzene ring where a carbon has been replaced by a nitrogen. Pyrrole is this 5-member ring, which we previously talked about. Notice the nitrogen in each case is position 1. Quinoline, another aromatic heterocycle, has a pyridine attached to a benzene ring. Imidazole, similar to pyrrole, is a 5-member ring, but this time it has 2 nitrogens. One of them will be position 1, the other one will be position 3. Indole is another aromatic compound, which has a pyrrole attached to a benzene. Pyrimidine is similar to pyridine in that it has a 6-member aromatic ring, but it has 2 nitrogens instead of 1. Pyrrolidine is a 5-member ring with no aromaticity, and piperidine is a 6-member ring that is also not aromatic.